Have you ever looked up at the night sky and just felt completely, utterly alone? Welcome to today's Explainer. We're going to unpack one of the most chilling, mind-bending concepts in both astrophysics and sci-fi, the dark forest theory. It's a concept that tries to solve a mystery that's baffled scientists for decades, basically suggesting that the silence of the cosmos isn't because it's empty, but because something terrifying is hiding in the dark.
So, we start with a foundational question, one that's beautifully captured by the famous Fermi Paradox from back in the 1950s. Physicist Enrico Fermi essentially asked this: if we know the universe is incredibly old, like over 13.8 billion years old to be exact, and mind-bogglingly vast, with the right conditions for life popping up all over the place, why haven't we heard from anyone? I mean, given the billions of years the universe has existed, an advanced civilization really should have colonized the galaxy by now. Or, at least sent a message. Yet, all we get is crickets. Where is everybody?
Just to grasp the sheer scale of what Fermi was dealing with, let's think about this staggering number. Physicist Brian Cox points out that based on telescope data, there are an estimated 20 billion Earth-like planets sitting right in the habitable temperature zone. And that's just in our Milky Way galaxy alone. 20 billion chances. To put that into perspective, that's almost 3 Earth-like planets for every single human currently alive today. 20 billion chances for life, sitting right in our cosmic backyard. Crazy, right?
But getting from a rocky little planet to a thinking, space-faring civilization? That requires incredible, honestly terrifying, luck. Look at the gauntlet life actually has to run. Our planet formed about 4.5 billion years ago, and simple life showed up roughly a billion years later. To get to us, it took an unbroken chain of life surviving asteroid impacts, devastating ice ages, mass extinctions, basically surviving the universe's incredibly violent history for nearly 4 billion years. It's literally a miracle we're here at all, which makes the search for anyone else who survived that exact same gauntlet even more compelling.
Section 1. The Dark Forest Theory, a terrifying cosmic solution.
So, in his acclaimed sci-fi series, The Three-Body Problem, and its sequel, The Dark Forest, author Lou Sixon presents the universe as this deeply terrifying survival game. He writes, "The universe is a dark forest. Every civilization is an armed hunter stalking through the trees like a ghost. In this scenario, because you can never guarantee the peaceful intentions of an alien species, and because cosmic resources are finite, the absolute only winning move is to hide. If you make a sound, the hunters will find you."
Which leads us to the formal definition of the dark forest hypothesis. It's the concept that, numerous alien civilizations actually do exist out there, but they are intentionally staying silent to avoid detection and destruction by hostile apex predators. And this theory is so compelling, it's actually influenced real-world astrobiology. Experts like Kelly Smith and John Traffigan advise that if we ever make first contact, our absolute safest move is to, quote, first do nothing. Think about it. If you hear a knock at your door in the dead of night and you don't know if it's a friendly neighbor or a heavily armed predator, your best bet is to turn off the lights and pretend nobody's home. You definitely don't want to broadcast your position.
It is worth noting exactly where this bleak outlook comes from in Lou Sixon's story. He uses the traumatic history of the Cultural Revolution basically as a plot device. It's a catalyst he needed to explain his main character's complete and total disillusionment with humanity. This profound loss of faith in her own species is what drives her to make a completely reckless decision to contact the unknown, ignoring the massive risks it poses to the entire planet.
Section 2. Flaws in the Forest, Deconstructing the Science and Math.
Because as captivating and terrifying as this idea is, we really have to look at the hard data. In Lou's universe, the forest is a silent arena of pure predation. But actual biological realities tell a completely different story. Real forests aren't like that at all. They are noisy, bustling ecosystems built on coevolution and mutual interdependence. Sure, predators and prey exist, but so do incredibly complex symbiotic relationships. Like environmentalist Rachel Carson famously said, "In nature, nothing exists alone. Life thrives on interaction, not just isolation and destruction."
Plus, we have to factor in the physics. A formal refutation by P.G. Musings shows that what we call a strong dark forest, where a predatory civilization flawlessly wipes out everyone else before they become a threat, would require mathematically impossible conditions. The predator would need universal reach across the entire cosmos and universal supremacy. But the cosmic reality? Light speed is a hard limit. A predator species can't just instantly wipe out a threat across the galaxy.
By the time they even see our signals, that image is thousands of years old. The massive scale of the universe makes absolute, immediate dominance practically impossible.
And this brings us to the actual math of survival, as modeled in that same paper. Imagine two critical variables for any civilization. First, you have the emission factor, or E, which is just your chance of being detected by others while going about your daily technological business. Second is the collaboration factor, or alpha. That represents the massive power boost a civilization gets from working together with others, sharing tech, trading resources, that sort of thing. When you put those variables together, you get an incredibly elegant equation. Full communication will be beneficial if, and only if, alpha is greater than 1 minus E. Simply put, if your camouflage isn't totally perfect, hiding is completely useless. If the technological boost you get from making friends outweighs the risk of being spotted, you are mathematically way better off shouting into the void. Think of it like this. If you're stuck in the woods and your hiding spot is already terrible, you might as well yell for help. Reaching out for an alliance is a much better survival strategy than just cowering in a bush.
Section 3. Humanity's Signals to Space, Stepping Out of the Shadows.
Speaking of making friends, let's see how this ties into our own history. Because instead of hiding in the bushes, we have basically been running through the forest with a megaphone. Humanity has actively played the exact opposite of the dark forest game. Starting with the Pioneer Plaque in 1972, our first cosmic message in a bottle. Right through to the privately funded cosmic calls starting in 1999, we clearly want to be found. We're making absolutely sure everyone knows we're here.
The most famous example of this is the 1974 Arecibo message. Sent by legendary scientists Frank Drake and Carl Sagan, this massive radio signal was blasted toward the star cluster M13, which is 21,000 light-years away. And man, we did not hold back. It was essentially an unprompted cosmic "you up" text. We sent the atomic numbers making up our DNA, our human population, about 4 billion at the time, and we literally drew a treasure map pointing right to our solar system. If the dark forest theory is true, we just handed the apex predators our exact home address. Oops.
But we haven't just been talking, we've been listening too. In 1977, we famously captured the WOW signal. This was an incredibly powerful 72-second flash of radio waves that perfectly matched the natural wavelength of hydrogen atoms. That is exactly the frequency scientists predicted an alien civilization might use to say hello. It was so shocking that astronomer Jerry Eschmann literally scribbled "wow" right next to the data on the printout. It's still one of the most compelling mysteries in modern astronomy.
Today, that search is more advanced than ever. The Breakthrough Listen initiative is actively using artificial intelligence to sift through the chaotic noise of the cosmos. By training machine learning algorithms to spot patterns, we're hunting for alien technosignatures, signs of advanced engineering or communication. Actually, an algorithm recently detected 8 highly suspicious radio signals right out of the static, reminding us that we really might not be as alone as we think.
Section 4. Fear, Hope, and Survival, Navigating the Unknown.
So how should we ultimately view our place in this vast, potentially populated cosmos? Well, our human anxiety about the unknown is perfectly captured by the character Q in Star Trek: The Next Generation. He tells the crew, if you can't take a little bloody nose, maybe you ought to go back home and crawl under your bed. It's not safe out here. It's a harsh truth, but it reminds us that the universe is wondrous, but exploration is absolutely not for the timid. If we want to reach the stars, we have to accept the risks that come with them.
Ultimately, how do we balance the terrifying concept of a dark forest with our innate human desire to connect? As noted in the Vixer paper on this topic, these cosmic threats are just unknown potentials. Our wisest path forward isn't to just stop exploring, but to navigate a healthy median between a paralyzing fear of the dark and naive hope. It means optimizing our collective existence right here on Earth, getting our own house in order, solving our own problems, and uniting as a species before we go inviting the cosmic neighbors over. So, as we wrap up this explainer and continue to scan the skies for anyone else out there, the real question we're left with isn't just about them, it's about us. If the universe isn't a dark forest, are we truly prepared for the profound responsibility of stepping into the light? Think about that the next time you look up at the quiet night sky.